Hello everyone, welcome to the Pandas second video. In the last video, we have understood how we can read the data from different data sources like Excel, CSV, JSON, list and dictionary and convert into the data frame. So in this video, we'll understand in depth other functionality, or let's say the data analysis part of the Pandas. So this video is going to be very interesting. Even the previous video was also interesting because we have understood how we can read the data from different sources. Still, we have not covered the SQL part, which we'll cover later on, I would say. So let's get started. Let's understand the other part of the Pandas. Perfect, guys. So I'm using the same IPynb file which I was using the last video. So now we'll understand in detail how we can do the data analysis and what are the, I would say, EDA exploratory data analysis we can perform on the Pandas. So in the last video, we were using the patient data, right? In the patient data, we have a two, I would say, seed 2026 and 2025. So I'll take any one of them because both are having a same data. So I'll take this one, let's say. Perfect. So let's copy this over here. And we have all this. Now, what I'll do that I'll make this short because this is the variable name is quite long over here. So it will be, whenever we write a code, we have to write a lot of, I would say, words over here. So I'll convert this into df. df equal to patient 2025 data. Perfect. Now we have this data over here under the df. The very first one is I want to know how many row and column we have. How many rows and columns do we have? So for this, we'll write df.shape. So once you write this df.shape, it will show you that in your data you have 1,000 rows and 7 columns. So if you check that, 1 2 3 4 5 6, but it's showing 6 only. What is the mistake? So I think you understand, we have added one more column, that is year. That's why it is showing the 7 column. If you check 1 2 3 4 5 6 7, perfect, and it has 1,000 row. If you see over here, it is mentioned. So similar way with the shape, you can find out there are thousands of rows and 7 column. Now if you write df.size, so it will show you the size of your data. So it has basically 7,000 KB. Perfect. Now the other one we have, I want to see the different, I would say, overview, or you can say the data types of my data frame. So what I want to show, what I want to see the data types and overall view of the data. What does it mean, overall view? Just let me write, then you will understand. df dot, I'll write info. As soon as you write info, it should not be this, it should be the function. So I need to use the parenthesis over here. As soon as you write the df.info, you will see that it will show the class pandas core frame data frame. So it is a data frame. Range is range index 1000 entities 0 to 999. It means that there is 1,000 entries or entities, you can say, a record, whatever. And the index is basically from 0 to 999. Data column, total 7 columns are there. And the column name over here and none count. So in the each columns you have 1,000 records. And why it is showing thousands records? Because none of the column having any null values. Null means empty. We don't have any empty values in any of the columns. Perfect. Now the data type. The patient ID is integer. Patient name is str. Object means str. A string, guys. Okay. Age is also what? It's an integer. Again, email, policy number, policy type, and these are the string, and your year is basically integer again. Memory uses, how much memory it is using, it is also showing. So this is the overall view of your data. I hope it makes sense. Now I want to see top 5 records. And this question has asked in one of the interview. The company name is TCS. So I think back in 2020, 2020. I'm not sure. I think 2024 or 2023. Not 2024, I guess. 2022. Yeah. 2022, I was giving an interview, and in the TCS, they asked me this question. They asked me to create one data frame using the dictionary, and then they asked me to show me the top 5 records from the given data frame. So how will you see, or how will you write a code that this should show only the top 5 records? So for that, I'll write df.head. So as soon as you write df.head, it will show the top 5 records, 0, 1, 2, 3, 4. If you count 1, 2, 3, 4, 5 records, right? All the columns, but only 5 row. Similarly, only bottom 5 records. How will you do this? So df.tell. If you write df.tell, it will show you the bottom 5 records. Perfect. Now the question is that I want to see 20 records from the top. So how will you do this? It's very easy. Df dot, you will write head, and over here 20. Done. So here is a 20 record of top. Now you want to see the data from the 21 to 30. What you will do? Can you write this df dot head 21 to 30? It will not work, because under the head you cannot pass like this. Or if you can think like I can pass the comma, no, or I can pass the list, no, this will give the error. You can only pass the 20, 30, 40, 25. It means that from the top to 25. If you use the tail over here instead of head, tail, tail, then it will show you the bottom, from the bottom 999 to the top 25 records. Perfect. So this is how you can see the top 5 records, top I would say bottom 5 records, and 20 records, whatever you want to see. Next, that I want to get only the column name. I want only column name, columns name. What you will do for that? Df dot columns. As soon as you write this, you will get only all the columns whatever is present in your data frame. Next, if I write df.describe, it will give you the statistical value of all the integer columns. Only the integer column, not the str. So patient ID was a integer column. So in that it's showing the count, it's 1,000. Mean, what is the average of that column? But there's no meaning of that. Patient ID is just the ID. It's like a roll number. What is the meaning of finding the average of your roll number? This makes no sense. But as it is an integer, it is trying to perform some of the statistical, I would say, operation. So basic statistical operation like a mean, standard deviation, mean, 25 percentile, 50 percentile, 70 percentile, or maximum values what you have in this. Okay, so just if you go to the age column, again you have a thousands of count in that age column. The mean of the age is 48, standard deviation is 18.36, minimum value, the minimum age in your data is 18, the maximum is 80, the 25th percentile is 32 age, and 50th percentile is 48, and 75 percentile is 63 actually. So these are the some, I would say, basic statistic which is you can get on the your integer columns using the describe. Perfect, I guess. All set. Now you are enjoying this. Perfect. Because see, Pandas is one of the easiest, I would say, library where you have to call just some of the modules function. It's basically a function of that module, and then, or you can say method of that module, that will help a lot you to perform a data analysis on the given data. Next, let's say that I have this df, right? I don't want to get all the columns. I want to get only one column. So I can just write, let's say dot, and I want to get age. So I'll write over here age. So I'll get this age over here. But this is not in the data frame, right? This is not a data frame. So what kind of this data, whichever I'm getting over here, what kind of data is this? So if you try to find the type of this, type of your this df.age, it is series. So now what is series? I think in the previous videos, I have explained that pandas return into two data type. One is the series, one is the data frame. Data frame is similar to the Excel, where you have a multiple columns and row combination. In series, what is series? Series is nothing but a one type of data type which is having a only one columns and label is index basically. So series is a type of data type which you have one dimension labeled array. It means it has a two main part, value and index. So as I said that series is a type of data type in the pandas which are having a one columns along with that one index. So that is called series. That's why whenever you want to get only one column from the data frame, you will get the series of that. So now let's one more question over here is how to create a series from the list. So let's say that we have one fruits, right? We have one fruits. It's, I think F is capital. Perfect. Now we want to create a what? Series of this fruit using the pandas. So what I'll do over here, I'll write over here, let's say series s equal to pd dot series, and you pass over here fruits and then s. So you have a series of this. As soon as we also have over here a price, right? If you see, we have a price. If you pass over here price, it is actually it should be this one. If you pass the price, it has 4 actually. Okay, then use append. Let's say make this append, let's say 30. Now it will be equal length. Why I got the previous error means because the length of your fruits and the price are not same. Now it is same, right? So what I'll do, I'll use the fruits and price both in the pd.series. Let's see what happened over here. And now it has executed. Now check this. So your price is working as the index over here and your fruits is working as a column over here. But if you want, you can pass this as a index. So over here you just write this and you have a, see, apple, guava, plum, all these are fruits are basically index over here and price is your column over here. Because in the series you have only one column and one label, that is index. So what is series? I think you understand now. Series is basically a data type in return of pandas which have a one dimension, that is one column and one index. Perfect. Now come back to our data frame. So let's remove this part from here and df. Okay, so we have this. Now what I want is I want to get only one column. So df.age I can write and I can get this. I think this is age. I can get this, and this is the series. Other way of writing this is df of under this age, and you will get this also. But if you write under the 2, I would say this square bracket, then it will be in the form of what? Data frame. Now if you check the type of this, it will be a data frame because I have passed under the 2 square bracket. And if you pass under the 1 square bracket, it will be a series, guys. Perfect. So now if you want to get more than 2 columns, then what you will do in that case? So we'll write over here, let's say df dot columns first to get all the columns detail, guys. Perfect. Now what I want, that I want the patient name and age both into a one, I would say instance. So at one instance, At one instance, I want the patient name, age, both. So what I'll do over here, df, and over here write this patient name. Always try to copy from this result of your columns, because sometime it can be typos also, or you may get the error. So it's always good to copy the column name and paste over here. Now enter this. You are getting the error. Why? Because you need to pass the column name in the list. So this is what you have done over here. Now you use the another, I would say, square bracket this. So over here you have a patient name and age. So I'm passing, if you have a more than one column, always pass that into data frame in form of list, and then use the square bracket, outer square bracket, for the slicing. This is called the slicing based upon the columns. If you want more than two, then you just add over here. Let's say you want the policy number, so add this policy number over here. Perfect, guys. Perfect. Now, so this is how you can slice your data based upon the columns. Now if I want, let's say I have this data, and I want from my 20 to 30 or 20 to 31, I want the records with all the columns. What I can do for that? So I'll write over here, get all the columns along with 20 to 30 rows number. So for that, df.iloc, I'll use, what is iloc? You will be surprised with that, but I'll explain it. Just give me a couple of minutes. iloc, and then I'll write over here 20 to 31 and comma and all the columns. So you can see, you can get from the 20 to 30 and all the columns over here. Now the question is, what is the iloc? So iloc is nothing but the index location, and the syntax of this, the syntax of your iloc is, first iloc data frame dot iloc, and then range of rows, comma range of columns, that you have to pass over here. So range of column I have passed from 20 to 31. Why 31? Because you know that the higher one get omitted, it will get ignored from the list. You understand this, right? So 20 to 31 I have given because I want to be printed over here as a result 20 to 30. That's why I've given here 20 to 31, guys. Perfect. And then I have given this over here. It means that I need all the columns, guys. That's why I've given over here only this double dot. So this is how you can get all the data from 2030 with all the columns. Now the next is, I want only patient name and policy type from 15 to 25. So let's write over here, get records from 15 to 25 index for a column patient name and policy number. So what you will do for this? So I'll write over here again this df.iloc, and over here 15 to 25. So 15 to 26 I will write. Next is patient name and policy number. So patient name is this and policy number is over here. So I should get, this is 0, 1, 2, 3, 4. So this is 1 and this is 4. Policy number, right? Or let's make this policy type, not policy number, because you will not see anything in the policy number, right? So that's why I need the policy type. So patient name and policy type. So patient name index is 1 and policy type index is, I think, 0, 1, 2, 3, 4 and 5. So I'll write over here 1, 5. and we are having a too many index. That's right. So let's pass this into the one list. So this is for the your columns and this is for your rows. Why I have passed into the list? Why? Because if I write, let's say over here, if I write over here 1 dot double dot 5, it means that 1 second, 1 colon 5, it means that I want all the data from 1 to 5. So see, 1 2 3 4 means it will get omitted the highest one. So I have taken all the index from patient to policy number, but this is not what I want. I want only this and this one. So if you want to pass both, then you have to pass in the list those index number, and you have the data from 15 to 25 with policy name and policy type, guys. Perfect. Next question will be that, let's say we have a thousands of columns, and if I want any specific columns, then we have to first count the index number of that column and then we have to write it over here. It is a bit tedious task, right? What I'm trying to say over here, let's say I have a total 20 columns over here and I want as a result 15 to 26, that is row number, and column position I want 17 and 19. Then how will you count? If you have a 1 to 20, how will you count that which column number is falling on the 17 and 19? So you have to manually count that, but this is tedious task, I would say that. Then what is the other way to achieve that? The other way of achieving that is df.loc, and you pass over here this, let's say 15 to 26, same row I want. In the column you pass the name of the column. So let's say I'll pass this patient name, comma, and policy type. Policy type is okay. Make this and now execute this and you will get this. Now your question will be, what is loc? Now I am get confused. So loc is nothing but location, and the syntax of this DataFrame dot loc over here, range of rows, comma, in the list, name of the columns. So with this, it will be easy to slice your row and column together, guys. Perfect. Next, let's say that I want to or let's get first data over here, df. Now next I want the data from 45 to 65 records for policy, let's say patient name and email, only these two. So what I'll do over here, df.loc, I said 45 to 65, so 66 I will take. Next I want the patient name, so I'll copy this and I'll paste over here. Perfect. Next, what I want this email, so I'll take this email and execute this. So you have from 45 to 66. It should not be 66, I say 65. So okay, let's take the 65 because it take what happened to the first one? Let me see over here. I have given 26. Okay, it is not omitting the highest one, so you can take this till 25, guys. This is also one of the interview question has been asked in the TCS. What is the difference between iloc and loc? So iloc is index location, where we pass the row range and column range to slice out the data frame, and the loc, that is location, where we pass the index, a row range along with that column name. So that is the difference between these two. And in the iloc, I think there's a mistake over here. Okay, this is a mistake, guys. I guess it is not a code, so it is not able to execute this. Okay, in the iloc, the highest range get omitted, but in the loc, highest values not get omitted. So these are the difference, guys. Perfect. You are doing good now. Okay, so next is how to rename, how to rename the columns. How to rename the column? Let's say that df dot columns I have. Now I want to convert this age as a patient age, or yeah, age as a patient age. So what I'll do, df dot rename, and over I'll pass columns equal to then a dictionary. In the dictionary, the first one should be the old name of the column. The old name of the column is age. Then that will be key, and the value will be new name of the column. So the new name of the column is patient age is the new name. And as soon as you do this, execute this, you will get as a patient age. But as soon as you execute in the next cell, it will be as it is, guys. It means that for this instance, the age has converted into patient age, but it has not changed the name into the schema. For that, you have to pass over here in place equal to true. It means that if you pass in place equal to true, means it will change for forever. It will go to the schema and it will change the name of your age column to patient age. But if you don't write this, it will change only for this instance. I hope I'm making sense. Now, as soon as you execute this, and it has been executed. Now, if you try to execute this, say it has been changed to patient age. So in place equal to true is important if you want to change the name of the column for forever. Okay. Perfect. You are doing good now. Now, let's say that you want to delete some of the columns, or before deleting, let's say that you want to change more than one column name. Then what you will do in that case? So let's say that I'll do it over here. Df dot rename and columns equal to, I'll pass the, let's say email to the patient email. I'll pass over here. So my key is the old name email, and it should pass to the patient email. Patient, let's say email. Perfect. Next is the policy number. I want to change into policy underscore NUM. So I'll take that and I'll pass over here policy number, and over here it should be policy NUM, guys. Execute, and it is done. See, policy num, and this email is a patient email. But I don't want to change this for forever. Just I want to show you, if you have more than one column, to change the name, how you can do that. You can pass over here as a key and pair value. Key will be the old column name and value will be the new column name of that corresponding name of the column. Okay, but actually I don't want to change for forever, so I'll not use over here in place equal to true. Perfect. Now we have this df. I want to, let's say, drop some of the columns. So this product patient ID is not making sense for me, so I want to delete this. So df dot drop columns equal to, I'll write over here patient ID. This is the patient ID I want to drop, and it has been dropped. But it has dropped for this instance, not for forever. If you check this over here, you have a patient ID over here. But for this instance, it is done. So now let's say that you want to delete more than one column. What you will do? You pass over here the column name in the list. So patient ID, and next let's say I want to delete the year. Perfect. So year has been deleted over here, but it will be available over here. Why? Because I have not used the in place equal to true, that's why. But as soon as I use over here in place equal to true, this both column patient ID and year will get deleted for forever. But I don't want to do that. If you write in place equal to true, it will be deleted for forever, but I don't want to do that, honestly. So I'll not do it. If you want, you can just try that. Perfect. Next, let's say that I want to find the index of my data frame. Index of my data frame. So index is from 0 to 1000. But this is the number it has. But I want to set patient ID as my index. So what I'll do over here, df dot set index, and I'll pass over here this patient ID as an index. And this is done. But if as soon as you check over here, this is not done unless you don't pass over here, comma, in place equal to true. This will not set your index as a patient ID. Now, if you check now, it is patient ID. So patient ID has converted into index, rest all is the column. So now if you check your df.sep, you will have how many columns? Right, 6 column. Why? Because one of the column is index. Oh, my bad. 6 column. Now, let's say that I have set this as a index, but I don't want to set as an index. What we can do that? So just write df dot reset index, and your patient ID will become as a column. Now, if you check over here, it is a okay, I should use the in place equal to true over here actually, or you can assign this directly. What you can do over here is that you can assign this over here, df equal to df dot reset index. Perfect. And now if you check this, you have a 7, and just check that dot head I'll use over here, let's say. So patient ID is one of the column now. Now what I want to arrange this data based upon the patient age. So what I'll do over here in the ascending order. So the lowest age should be on the top and highest age should be at the bottom. So what I'll do, df dot short value by, and over here I'll pass, let's say, patient age. I'll pass. Data frame has no attribute short value. Short, I think it's a values. Yes. See, it is from 18 to maximum. Now, if you want to make it descending order, then what you will do over here? You just write over here ascending equal to false. It should be small, ascending. Now let's try. Yes, so it has taken from the 80. But if you check over here as a df, it will be mixed. Why? Because I have not used the in place. So if you write over here in place equal to true, so it will rearrange your data forever based upon your age from highest to lowest. Now if you check this, your df, so it is from 80 to 80. Now if you want to make is ascending order, you just remove this part and it will arrange your data into ascend based upon the age, ascending order from lowest to highest. Perfect. This is what it is. Now if you want to arrange in descending order, you write ascending, ascending equal to false. I forgot the comma over here. See, this is one of the easiest, I would say, module, right? You are writing like it's not a code at all. See, it's like a plain English and some of the special character, that's all. Next, I want to see that in the policy type, how many policy types are there. So what I'll do over here, df dot or df of this policy type dot unique, and use this maybe. Then you have a platinum, you have a premium, you have a gold, and you have basic. If you want to know the number of unique policy type you have, you can just take this over here and then you use over here n means it will give the number. So you have a 4 different type, 1 2 3 4 right over here. Get the unique type of policy data has. And over here, the number of, get the number of unique policy data has. Same apply for your age also. So you can write over here dot age, and I think age is patient age. Now take the patient age dot and just get this unique. So these are the unique age you have in the as descending order, because you have arranged this in descending orders. Perfect. 18, 19, 20, 21 till 18. And if you want the numbers, so you just take this from here to this cell and you use over here n, and you have this. Perfect, guys. So I don't want to make this video lengthier. Still, we have a lot of things in the pandas to learn, so we'll cover in the next video. So this video I'm stopping here only, guys. So thank you so much for bearing with me till now, and if you find this video interesting, don't forget to share, like and subscribe, because it takes a lot of effort. Thank you so much. See you in the next videos of pandas.